Today we're going to be talking about isosceles triangles. Isosceles triangles are two triangles with equal sides and two equal bases included. So the drawing of this triangle blue is an isosceles triangle. And if we label, these two legs are equal and these two base angles are also equal in measure. The angle at the top is what we call the vertex angle. That angle is not going to be equal to either of the other angles. The two sides that are equal, we call those legs. The side on the bottom is called the base. And the angles on either side of the base are called the base angles. Those two angles are going to be congruent. So now that we know the parts of our isosceles triangle, what we're going to do is we're going to go ahead and take a look at other parts. So in summary, we have two equal legs of the triangle, those two sides, and then two equal base angles in an isosceles triangle. So keeping that in mind as part of the definition of what an isosceles triangle is, we're going to take a look at what happens when we cut out this triangle, and we're going to see if we notice anything. So if you have paper, you can go ahead and do this as well. Cut out an isosceles triangle where two of the sides are equal. So once this triangle is cut out, what we're going to want to do is we're going to fold it along the middle. So we'll take the triangle with the two legs on either side and the base angle and the base on the bottom. We're going to fold it in half lengthways like that. And we're going to want to make sure that we match up the angles and make a nice fold there. So we're folding the triangle in half along the line that's halfway between each of the base angles. And you can see that crease there. We're going to mark that side, so get it nice and straight. So this line in the middle that we folded on is actually bisecting the angle at the top of the triangle. You notice that this line we just made is perpendicular to the base, so it forms 90-degree angles with the base. And we can also see that if you fold it up, the two endpoints here, those angles, those are the same measure because they are the same degree. If you flip it over, it just looks like one angle. So that is part of where the proof of those two angles on the bottom, the base angles, are equal. Also, you can see these sides here. These legs are both congruent because when you fold them, they're exactly the same length. So we have two equal legs as well, or two equal sides on this isosceles triangle. So if you're looking, two base angles that are equal, and then two equal legs on the isosceles triangle. Now, if we have an isosceles triangle and it's labeled ABC, and we know that those two sides are congruent as we're marking, we're going to prove what's called the isosceles triangle theorem, or we're going to take a little bit more of a look into it. So we have our picture of our isosceles triangle in blue here just to kind of remind us of what it is. But when we're looking at this isosceles triangle, one thing that we can notice right away is that side AB is congruent to side CB. We know this because it's an isosceles triangle. So triangle ABC is isosceles, and that's part of the definition of being an isosceles triangle. So we're going to write down a few more things that we notice about this triangle. If we go ahead and draw that line down the middle like we did before, what we can kind of see is that the line we're drawing in the middle makes a 90-degree angle with the base. We're adding a point D where that line connects to the base of the triangle. And you can notice that since this line we drew is a bisector, it is cutting those two angles in half. So BD is the angle bisector of angle ABC in this triangle. And so being an angle bisector means those two small angles at the top marked in purple are equal to each other. So we have those two angles right there from the bisector. We also know angle BAC and angle BCA are congruent because triangle ABC is isosceles. Those are our base angles that we're talking about now. So we're proving a lot of different things about this triangle. So that's one thing you can look at when you're looking at isosceles triangles. Now, if we want to look at an example using isosceles triangles, we're going to go ahead and assign some values and look at how we might solve a problem with missing angles here. So we have an isosceles triangle that we're going to draw for example 1. Our two legs are marked congruent. So we're starting with the fact that it's isosceles. Those two legs are marked congruent. The angle at the top there is 80 degrees, and we want to know what both of those base angles are equal to. So all we're given is that the vertex angle is 80 degrees. So angle C is 80 degrees, but we do not know anything else. We do know that in a triangle, all three angles add up to 180. So angle A plus angle B plus angle C is 180. We're going to go ahead and write that out and then replace angle C with 80 degrees since that's what we're given. If you subtract angle 80 from both sides, we're kind of simplifying our equation. We have angle A plus angle B is equal to 100 degrees. And so another thing that we can remember with isosceles triangles is that angle A and angle B have the same measure because triangle ABC is an isosceles triangle. And since those are our base angles, they're going to be equal. So since those two angles are equal, instead of A plus B, we have 2 of angle A. They're literally the same, we're just changing the name. And to solve for that, we can divide by 2 on both sides, and 100 divided by 2 is 50 degrees. So this tells us that angle A and angle B are equal to 50 degrees. Those are our base angles. All right, so that's looking at a problem with one angle given and 2 angles missing. We're going to look at a different case here. So we're starting with an isosceles triangle again. And this time we're given 2 angles. We're given a vertex angle and then a base angle, but we are given it in the term of formulas here. So the vertex angle is equal to 3x minus 1, and one of the base angles is equal to 2x plus 3. So one thing to remember when we're working with triangles is that all angles add up to 180. That's the triangle sum theorem. So if we label these sides, we have A, C, and B. We know A and C are represented by certain algebraic expressions. We also know that angle C and angle B are equal to each other because triangle ABC is an isosceles triangle. So since we know that both of those sides are equal as well, but most importantly, those 2 angles are equal. So when we're looking at that, we know that angle A plus angle B plus angle C is 180 degrees as we wrote up above. We're going to go ahead and replace the angle with the algebraic expression that represents that angle. So A is replaced with 3x minus 1, and B and C are both replaced with 2x plus 3, since that is the algebraic expression that is describing that angle. And all of that adds up to 180. So from this step, we're going to want to combine like terms so that we can solve for x and figure out eventually how much these angles are actually measure. So we're combining like terms. We see all the terms with the x. We're going to group them together. So we have 3x plus 2x plus 2x. All right, and then we're going to take another grouping of all of the constants or all of the numbers without variables attached. So we have a minus 1, a plus 3, and a plus 3, and we're grouping all those together. All of that's equal to 180 degrees. So again, if we're grouping together our expressions with variables and then our constants, 3 plus 2 plus 2 is 7 with an x attached. And then if we're grouping together our constants or our numbers without x's attached, if you combine -1 and then 2 positive 3's, that leads us to positive 5. We're going to subtract 5 from both sides to simplify. So we have 7x equals 175. In order to continue solving, we're going to divide by 7 on both sides. So x is equal to 175 divided by 7. And you can plug that in a calculator, x equals 25. So in this problem, we were just asked to find the measurement of x. All right, so another thing just to look at is the fold in this triangle. So the fold in the middle of the triangle. When it's an isosceles triangle, it is perpendicular. That upside down T symbol means perpendicular to the base. So that's why we can draw 90-degree angles at the base there. And again, a reminder, that symbol with the upside down T means perpendicular. So this will be helpful later on, but that fold makes a line that's perpendicular to the base. It's an angle bisector. And in triangles, when an angle bisector is perpendicular to the base, this line can be called either the altitude or the median. We'll see different times when we use each of those terms.